Welcome back to Mrs. Neller's notes for double block algebra. These are the notes for section 2.6 entitled The Distributive Property. Today's objective is to use the distributive property to rewrite expressions. And these notes are from section 2.6, so I know these are in chapter 1, but we're doing a couple sections from chapter 2 along with chapter 1. And the very first thing we're going to do is we're going to find the area of a rectangle whose width is 4 and whose length is x plus 3. Now I'm going to draw a rectangle for you, and I'm going to draw it a little bit special. Okay, so there's our rectangle, and let's say that this is its width of 4, and its length has to be x plus 3. So part of it is x and part of it is 3. I'm going to draw in this little imaginary line here. And this little part of the rectangle, we'll call that x. And this part over here, we'll call 3. And if we added these two values up to get the whole length, that would be 3 plus x, or x plus 3. Okay? Now this is a way to kind of visually see what the distributive property does for us. So if I was going to find the area of the whole big rectangle, really I could find the area of the one on the left, and then find the area of the one on the right, and then add them together. So to find the area of the rectangle on the right, I would do length times width, which would be 4 times 3. And then to find the area of the rectangle on the left, I would do length times width again, which would be 4 times x. And then I would add them up. Now I don't really know what x is, so here I can't actually have that value. I can't substitute in a value for it and multiply and add and get an actual number. I'm going to get a variable expression. But I can simplify 4 times 3. That's 12. I'm going to write it down here for just a moment. And then I can simplify 4 times x just a little bit. I can write it 4x. Remember, even when expressions are written with a dot or with the number and the variable right next to each other, it still means multiplication. So technically, this is my area of my rectangle, 12 plus 4x. But I'm going to put in a little step in the middle here, and this kind of shows what the distributive property helps us do. Notice that I have a 4 here and a 4 there. So what if I just pulled that 4 out front? And then put everything else that's left over in the parentheses. So if I took the 4 out of this 4 times 3, I would have a 3. And I have the plus. And if I took the 4 out of the 4 times x, I'd have an x. Look at that, finding the area of the whole rectangle, the big rectangle, would be 4, which is its length, times its width, which is x plus 3. And what the distributive property does is it takes that 4 and it multiplies it by the 3, and then it multiplies it by the x. So I actually get that expression up above, which is what we started with. And then I'll be able to simplify that down to get my value at the end. So I've drawn it a little bit out of order, but this is basically what the distributive property lets us do. It lets us take a number out front of the parentheses and multiply it by everything inside the parentheses. So we have a more simplified expression. It gets rid of the parentheses after we distribute. So let's look at our rules down here for the distributive property. If I have, in this first expression, an a out front, the distributive property tells me I can take that a times everything inside the parentheses. So it's kind of like if you go to a wedding and there's a person standing at the door and they give a program to everybody who goes through the doors. So we're going to have A times B. That means person B gets a program when they go through the door. And we're going to have A times C. So person C gets a program when they go through the door as well. So now they've gone through the doors, everybody has a program, they're ready to go. And this works the same when you have the A, sorry about that, written behind the parentheses as well. We can have A times B plus A times C. So these two expressions are exactly the same, and you can even rewrite it. If you don't like the A being written behind the parentheses, rewrite it so that's written in front of the parentheses. That's totally legal to do. And the rules work the same for subtraction. The A is still going to get distributed or multiplied by every term inside the parentheses. So we'll have AB minus AC. But subtraction is a little bit different for this other one. Or is it? We'll have A times B and A times C. So A times B minus A times C. Look at that. We still got the same answer. So again, these expressions are the same. It doesn't matter if the A is in the front or if the A is behind the parentheses. When you distribute, you're still going to get the same expression. Whoops, did I skip example 1? Oh no, example 1 was the area problem. Okay, moving on to example 2. So now, this is usually what you're going to see more of when you're using the distributive property. You're going to have a term out front of the parentheses, like in part A, and you're going to distribute it to everything inside the parentheses. And remember, when we're distributing, we're really just multiplying. So I'm going to multiply 5 by the A and 5 by the 2. And I'm going to leave the sign, the plus sign, between my two terms. Now 5 times A, I don't know what that is, so I'm just going to write 5 times A plus 5 times 2. Now I can simplify that, and I can actually simplify the 5 times A. I'm just going to write 5A plus 5 times 2 is 10. There we go. I have simplified that expression as much as I possibly can. Do not add them together. That's a common mistake that students make. They add the 5 and the 10 and they put 15A. Okay, so I'm going to put a little note here. Do not add. We can't add these terms together because they're not like terms. One of them has an A, one of them has a variable, and the other one doesn't. So they're not the same. You can only add expressions together in math when they're exactly the same. Now in part B, oh my goodness, the 4 is written behind the parentheses. But remember, that doesn't matter. And if you want to rewrite it so that the 4 is out in front, you can. Either way, we're going to take the 4 times the A and then the 4 times the 1. So 4 times A minus 4 times 1. I'm going to give everything in the parentheses a 4. So 4 times A is just 4A minus 4 times 1 is 4. And I'm done. Don't combine them. Don't subtract the 4's. Don't write 0A. That's not right. They're not like terms. You can't combine them together. And the only thing different about part C is that there's a negative in front of the number out front of the parentheses. And there's also a 3n. We have a number and a variable that we're going to multiply by the negative 9. But here when we distribute the negative 9 to the 3n, what can we really multiply together? We're only multiplying the 3 and the 9 together because they're the numbers that we can actually multiply together. So it's kind of like negative 9 times 3 times n. And then here we're still going to leave our minus. And then we're going to have a negative 9 times 2. Now I'm going to put this negative 9 in parentheses. just so I know that the negative stays with the 9. Now this negative 9 times the 3 gives me a negative 27 times n. And then I have a negative 9 times 2, that's minus. Negative 9 times 2, that's a negative 18. Now what happens when you subtract a negative? That's what you need to be asking yourself right now. What happens when I subtract a negative? When you subtract a negative, I hope you're remembering that it turns into plus a positive. So this is negative 27n plus 18. Now that expression is as simplified as much as it can get. Don't take negative 27 plus 18. Remember, they're not like terms. Now part D, sometimes students freak out a little bit about this because it's a fraction. And again, remember, the fraction that we're distributing is written behind the parentheses, but that doesn't matter. If you want to rewrite it in front, so you have negative 1/8 times 5y plus 3, that's okay. You can do that. It's the same thing. So I'm going to have a negative 1/8 times the 5 and the y. I'm just putting a little 5 and then dot and then y, because remember, they mean the same thing. 5y written next to each other and the 5 dot y, they mean the same thing. Okay, I did that over in example C as well with the 3 and the n. So I've distributed the negative 1/8 to the 5y. That's why I'm drawing in these little lines or these little rainbows to show that I'm taking that negative 1/8 and I'm distributing it to the 5y. And then I'm going to have my plus. And then I'm going to multiply the negative 1/8 by the 3 as well. Now, sometimes when students see fractions, they get a little freaked out. But remember, you can make any whole number into a fraction by putting it over a 1. So now I'm multiplying two fractions. And when you multiply fractions, you multiply across, straight across. So here, I can take my negative 1 times 5, which gives me negative 5. My 8 times 1, which is 8. And that'll be times y. Plus negative 1 times 3, that's a negative 3. And 8 times 1, that's an 8. Now really when we add a negative number, that's okay if you want to leave the expression written like that. Adding a negative number, that's okay. But if you want to be super duper simplified, let's write negative 5/8 y minus 3/8. Remember, adding a negative is like subtracting a positive. So now that expression is as simplified as it can get. Part E, sometimes students get a little scared by part E because they see the little negative sign outside the parentheses. You want to think of this as a negative 1 and then the parentheses, x plus 12. Okay. Anytime you just see a little negative like that, think of this 1 as like a little ninja. He's hiding. He turns invisible. So if you want to write him in, you can. So now we're going to take that negative 1 and I'm going to distribute it to the x and I'm going to distribute it to the 12. Now here I wrote my little rainbows underneath just because of space. If I would have written them up above, I would have gone in the original problem and covered it up. Okay, so I'm not doing anything different. I'm still distributing the negative 1 to the x. So negative 1 times x plus, and I'm going to have my negative 1 times 12. Now negative 1 times x is just negative 1x. And negative 1 times 12 is negative 12. Now again, I'm going to rewrite this just like I did in my last example. Instead of plus a negative 12, I'm going to write negative 1x minus 12. And if you wanted to just write negative x minus 12, that's okay too. If you wanted to turn that 1 back into a ninja, you could. Okay, last example, part F here has another fraction. Again, he's written behind the other parentheses, but that doesn't matter. We're still going to distribute. We're going to take the negative 1/4 times the 2 and the negative 1/4 times the n. I'm sorry, positive 1/4. So 1/4 times 2 minus 1/4 times n. Now remember, I can put this 2 over a 1. So 2 times 1 in my numerator is 2. 4 times 1 in my denominator is 4. And I'm going to reduce that. We always want to reduce fractions if we can. And then I'll have minus 1/2 n. And 4 over 2 is really 1/2. So 1/2 minus 1/2 n. Wait a second. Why did I write a half? That's not supposed to be a half. That's supposed to be a 1/4. Good thing I caught that. All right, there we go. 1/4 n, and 1/4 n, and 1/4 n. There we go. So I distributed the 1/4 times the 2 and got my 1/2. 1/4 times the n, my 1/4 n. There's my simplified expression. Remember, don't combine them together. Don't take 1/2 minus 1/4. This 1/4 has an n, so they're not like terms. It's like apples and oranges. There's a little note here that says, don't add or subtract the numbers. They're not like terms. So I've said it about 5 or 6 times now, and then it's written in the notes as well. So it must be really important to remember not to combine the unlike terms. Okay, I think number 3 is our last example here. It has a pretty little picture already drawn for us. And we want to use this diagram. So you're going to see some diagrams like this in your homework as well in your book. We're going to use this diagram to find 2 expressions for the area of the rectangle. So this is similar to what we did in example 1. Okay? You want to think of this whole side as having an x part and a 75 part. Now if I combined this whole side, I would have 75 plus x. So if I wanted to find the area of the entire shape, I could write it 2 different ways. That's what the first part of this problem says. It says write 2 expressions for the area. So I'm going to take my length times width. If I'm finding the area of a rectangle, area equals length times width. That's a formula that we know. We know that. So I'm going to use that. So my area is going to be my length, 125, times my width, 75 plus x. So that's one way to write the expression. The other way to write the expression is to distribute. And I can distribute the 125. Okay? So if I actually do that, if I actually distribute the 125 to the 75 and then to the x, I get 125 times 75 plus 125 times x. 125 times 75, you want a calculator for that. That's going to be 9,375 plus 125x. So I'm going to circle these in a different color. I'm going to circle these in blue. Okay, so here is one way that I can write the expression. Here's another way that I can write the expression. So those 2 expressions, they are equivalent. They're equal to each other. And that's what the distributive property does. It takes an expression with parentheses and it reworks it into an expression without parentheses. Now there's another part to this problem. I'm going to finish that up in green. It says if x is 50, what's the area of the rectangle? So I could use either expression, either the first one or the second one, and substitute that value in for the x and simplify. So if I substitute it into this second expression, I'll just pick the second one, we would do 9375 plus 125 times 50. Now 125 times 50, we want to simplify that as well. So we have the 9375 plus 6250. I'm doing order of operations here to simplify. I'm doing my multiplication first. Now I'm going to add. I get 15,625. Now it's area, and we don't know if it's feet or inches or meters or miles or acres. We don't know. So I'm just going to put a little U for units, but then since it's area, it does have to be squared. Now I could do that with the other expression as well. I could take 125 and then the 75 plus 50 if I substitute in the value for x. And then I'm going to do 125 times 75 plus 50. That's another 125. And 125 times 125 should be 15,625. So whichever way you decide to do the problem, if you simplify using the first expression or if you simplify using the second expression, you'll get the same answer. And that's the beauty of math, is that you can do one problem two different ways and you can get the exact same answer. So if it makes more sense for you to write it and simplify it with the parentheses, do that. If it makes more sense to distribute and then substitute, you can do that too. So tonight's homework is on the last slide here. These are your problems to practice these concepts on your own. Good luck, and I'll see you in class.